Ready?
figure that out together.
Alright, so we can
Is
first
that one
start out
question?
by
What does
writing
it
our
ask? What about 6.5?
givens here. So we're gonna have the mass as
Is that
1500
multiple steps?
kilograms. The coefficient of friction is going to be equal to 0.55.
This should be.
The change in x is going to be equal to 62 meters because that's how far he went on the car went on the skis. Then we can also say that velocity final is equal to 0 meters per second because that's when the car stops. And so what we're trying to find is velocity initial before the car skids. And we're also trying to find the acceleration of x. So we can start off by writing the free body diagram here. We have a force going up, that is force normal. A force going down, that's force of gravity, and a small force in the negative x direction, which is our force of friction. So then we can write our equations down. So the sum of the forces is equal to MA, and then F net x is equal to MAX, F net y is equal to MAY. So after that, we can then write down our forces right here. So we have force normal plus force of gravity plus force of friction, and that's going to be equal to mass times acceleration vector. So after that, we can do our column addition. Equals. Okay, so in the x direction, we have this is 0 force normal because it's in the y direction. So then we can just single that out to the y. And then so for force of gravity, there isn't any in the x direction, but there is in the y direction. That's always going to be a negative force of gravity. And so force of friction, we can see that it is negative. So force of friction is negative in the x, and there is no force of friction in the y direction. And so we can equal these to MAX and MAY. Then after that, we can simplify these to okay, so we can rewrite our zeros, and then we can say that the negative force of friction is equal to the negative coefficient of friction times Fn. So we can just write that in right here. So it's going to be the coefficient of friction times F of n, and then for our force of gravity, we can say that negative negative Fg is equal to the negative mass times gravity. And then we can just rewrite the Fn. So after that, we can then say, we can take, oops, I didn't do this yet. So there is no acceleration in the y, and there is acceleration in the x, and that's what we have to find. So we can then take our equations here and So we can say that negative coefficient of friction times Fn is equal to max, and this can be rewritten as a negative coefficient of friction times mg over the mass times acceleration, and because this is still what we're trying to find, so we gotta single that out. So then we can then simplify this equation into a negative coefficient of friction times gravity, and that's going to be equal to our ax. So then we can say that we can plug in our numbers here and say that the coefficient of friction, which we know is 0.55 times 9.8 meters per second, that's going to be equal to the acceleration in the x direction, which is going to be equal to a negative 5.39 meters per second squared, and that's going to be our acceleration. So we have the acceleration, and we still need to find our velocity initial. So with doing that, we can write down the equation of velocity final squared equals velocity initial squared plus 2ax change in x. So we want to isolate the velocity initial. So we can say that vi squared is equal to vf squared minus 2ax change in x, and then we can say that vi is equal to the square root of vf squared minus 2ax change in x, and then we can plug in our numbers here. So that is equal to, so we know that the velocity final is equal to 0, so we can just cancel this out. So it's going to be a negative 2 times our acceleration, so negative 5.39 meters per second squared, and then the change in x, which we know is 62 meters.
So we're just changing this ball.
So then vi is equal to 25.85 meters per second.
FGX minus FX.